All right, here we go. This is part 2 of our duopoly lecture. So we are doing our Cournot model derivation for two firms profit maximizing, knowing that their individual output is only going to be part of the total queue that determines a market price at which they can sell their goods, right? So we have our inverse demand function up here. P is a function of Q. Total supply here is going to be little q1 plus little q2. And each firm has profit, P of Q times their own little q minus the total costs of their little q. We're going to look at two different cases. This is all symmetric cases where the cost function is the same for both firms, right? But in case 1 here, we're going to allow that the cost function is such that we have constant marginal costs. So marginal cost is just going to be equal to C, right? So, and then in the second case here, right, our marginal costs are going to be increasing. Still, symmetric costs, both firms have the exact same cost function, but their marginal costs are going to be K times QI, right? We take a derivative of that function there, and we get this. Right, so case 1 will have constant marginal costs, case 2 will have increasing marginal costs, and from here on out, I'm going to let I equal 1. So we will profit maximize for firm 1, just knowing that that firm 1, firm 2 have the exact same problem. So I'll be able to reverse the subscripts if I want to look at the same solutions for firm 2, right? All right. So as stated in the last section, right, we're just going to maximize profits for each firm, given whatever the output is of their competitor, because that is Nash equilibrium. Take as given, well, that's how we find a Nash equilibrium. Take as given the strategies of all others and play your best response. If every player is playing their best response simultaneously, that's our Nash equilibrium. So we want to maximize I1, right? And that is going to be P of Q times Q1 plus C of Q1, which, right, plugging everything in here, is A minus B times big Q. Times Q1. And for this first problem, sorry, that's a minus. For this first problem, it's a minus F minus C Q1. Right? And so now take a derivative of their profit with respect to their output, set that equal to 0, right? And we will get this first one, we take a derivative with respect to big Q and get minus B times Q, derivative with respect to Q, derivative of Q with respect to Q1 is just equal to 1, right? So that is going to be minus B, minus B for the derivative of this term times that, minus BQ1. And then this term times the derivative of that, finish our product rule, and that's plus A minus B big Q. And F does not have any q in it, so it is 0 in our derivative, and then minus c equals to 0. So that is what we might call the first order condition for maximizing the firm's profit. Now I'm going to expand this out and add this to the other side. So we have minus b q1 plus a minus b q1 minus b q2 equals c. Right? Or I just plugged in that q is equal to q1 plus q2. And now that is a minus 2b q1 minus b q2 is equal to c. All right? Note that back here I could have plugged in that that q is equal to q1 plus q2. I would have had a minus b q1 squared minus b q1 q2, and taking a derivative of that with respect to q1 would have given me exactly this right here as well. Now, I want firm 1's best response function, right? So that is, what is the optimal choice of q1 given the whatever choice of q2, right? So solve this for q1 in terms of q2. So I'm going to add, also note before we do that, right, that this is our marginal revenue and this is our marginal cost. So our tip are always, always, always set marginal benefits equal to marginal cost in order to maximize the objective function, and that is that version of it, right? Now I add 2bq1 to this side and subtract a minus c over here and get we call this q1c for Cournot is equal to 1 over 2b times a minus c minus bq2. Which is our best response, right? Best response for firm 1 to q2 is this function over here, right? Best response for firm 1 to the actions of firm 2 is going to be choose their own q1 according to this function here, which we could further simplify, right? Since we have a b here, you might consider this a more simplified version, to say 1 over 2b a minus c minus 1/2 q2. Right. So we know how firm 1 will respond to firm 2, right? There are two ways that I can proceed from here. I can set up the exact same sort of function for firm 2 and sub 1 into the other, right? Which is the way we would have to solve this in an asymmetric case. However, this problem is symmetric, and so what I know is that when both firms are playing their best response, because both firms are solving the exact same problem, that Q1C is going to equal Q2C, right? They have the same cost functions. They're subject to the same inverse demand and all of the same conditions, right? So, so it must be that both of them simultaneously solving their their profit maximization conditions will result in the same solutions to their problems, right? So the quick way to get through this is say Q1C is equal to Q2C, right, is just equal to little qc. So I have QC is equal to 1 over 2b times A minus C minus 1/2 QC. So I just add this QC over here, and that's going to give me 3/2 QC equals 1 over 2b A minus C. And therefore, multiplying both sides by 2/3, I get that QC is equal to 1 over 3b, or 1/3 of 1 over b times A minus C, right? Where A is our price intercept for the inverse demand function, and C is the marginal cost of production. Let's bring these over here. So the best response function for firm 1 responding to firm 2's output choice is going to be 1 over 2b A minus C minus 1/2 Q2. Okay? And the output choice for either firm is going to be QCI is equal to 1 over 3b times A minus C. Now, before we back this up and start over for the second case here, let's verify that what I did here was legit. All right, so what we have is that Q1C is equal to 1 over 2b A minus C minus 1/2 of Q2, right? And so I know that if I solve that exact same problem, I'll come up with the same thing for the second firm, right? Essentially, that Q2C is equal to the same thing where I just flip around the subscripts, right? So let's take this and plug it in there and solve it down. Okay, so I have Q1C is equal to 1 over 2 B A minus C minus 1/2 of Q2C, which is this. So now plug in what Q2 is equal to, and I have 1 over 2B A minus C minus 1/2 Q1. I'm going to keep that C there with that Q1. right? So what I've done now is I've said this is firm 1's best response to firm 2's output choice. And this is firm 2's best response to firm 1's output choice. I want them to be solving those simultaneously, right? And this works even if I don't have symmetry necessarily. Then I can take this and say that's what Q2 must be, right? In order for both of these conditions to be satisfied at the same time, and I sub in this whole term into Q2. So that is necessarily both conditions being satisfied at the same time, which is our Nash equilibrium. And all I need to do now to get the closed solution is solve for Q1. So I need that Q1 to end up over here and to simplify this whole mess here. So I've got 1 over 2b a minus c minus 1/2 times this, so that's 1 over 4b a minus c, and minus 1/2 times minus 1/2 c is plus 1/4 Q1c. So I just distributed the negative 1/2 onto those two terms. Now I'm going to subtract 1/4 Q1c from this. So I have 3/4 Q1c is equal to these two terms, right, for which I can factor out the a minus c, and what I have is 1 over 2b minus 1 over 4b a minus c. What are these together? That is 1/2 minus 1/4 with a b multiplied in, right? Or this is 2 over 4b minus 1 over 4b, which is now note, I just multiply through by 4/3, and I'm going to cancel out that 4 down there and replace it with a 3. So I get Q1C is equal to 1 over 3b a minus c. Surprise, the exact same thing as I got when I just imposed that Q1C is equal to Q2C. And if you'd like, you can then also double, triple check, verify that you got this right by plugging in that value of Q1C right here and showing that Q2C ends up being the same. Basically, for either one of them, right, their total output is going, their individual output, excuse me, is going to be 1/3 of 1 over b times a minus c, and the total market output, big Q, right, is just going to be 2 times that, so it'll be 2/3 of 1 over b times a minus c. All right. Now, what happens when we switch to case 2? Going to look much the same, right? The only difference here is that we have that as our cost function, and therefore, taking our derivative, we'll end up with minus b q1 plus a minus b big Q is equal to, minus k q1 equals 0. Now I can add that over there to have my marginal revenue equal to marginal cost form, right? Where this is marginal revenue for firm 1 equal to marginal cost for firm 1. And I get my, and now I solve this, right, in the same way I did before. I can get 2b q1, but now this term is going to have to stay attached to it, right? Stay on that side because I'm solving for q1. So I have plus k q1 is equal to a minus b q2. This one won't simplify quite as neatly. We get q1c is going to be equal to 1 over 2b plus k times a minus b q2. However, at this point, I can also, well, we're gonna keep it simple, right? This is our best response function. Sorry. Didn't leave myself room for the subscript. So as before, that's the best response function from one's choice of Q1 in response to a given quantity chosen by their rival. Note that this Q1 could take on almost any value between a over 2b plus k and 0, depending on what exactly the value of Q2 is. But there's only a particular value at which this will be true, and firm 2 will also be maximizing. Just like before, their functions are identical, right? The maximization problems are the same. So this time, I'm not going to do it both ways. We are just going to come back up to this step because it's a little easier for the simplification, and say that Q1 is equal to Q2 for QC, right? So now from there, I'm going to come around to got the 2BQ, sorry, here we go, 2BQ plus KQ, and then add another BQ is equal to A. That's 3BQ plus KQ. Factor out the Q and divide through, and we get QC is equal to A over 3B plus K. So our best response function in this case is, best response for firm 1 is to choose a Q that is equal to 1 over 2b plus k times a minus bq2. And the resulting Nash equilibrium is for both firms to have QIC equal to a divided by 3b plus k, where k is our marginal cost. Notice that in both cases, right, C is marginal cost here, k times qi is marginal cost over here, and if we let that marginal cost increase, right, firms produce less. Same here. Firms produce less when their marginal cost increases. Firms produce more if the highest willingness to pay increases, so demand expands essentially, right? So we can identify several factors in these that make sense with what we know about firms. And one last thing to look at here, right? So these are the Nash equilibrium outcomes, and you could sub in actual values, right? So A could be 100 minus 1/2 big Q, right? And we could put in particular values for our constant marginal cost or our increasing marginal cost over here, and everything will work out just the way we did here. But what is the socially efficient outcome, right? Just like with a monopolist, we wanted to compare the monopolist's profit maximizing choice with the socially efficient outcome. We can look at the same thing here, right? And because, so we'll just use this case here where marginal cost is equal to C. What I know is that means this is the marginal cost curve, which are the marginal social costs, and this is the demand curve, which is that inverse demand right there. It is very easy for me to find this socially efficient outcome, right? This marginal cost in the absence of any externalities is the marginal social cost. And so I can say that for that socially efficient outcome, what I want is marginal social cost equal to marginal social benefit. That is, marginal social cost is just the marginal cost of the firms. So that is C, cost them C to produce each unit of output. And marginal social benefit is the willingness to pay for each unit of output. That's A minus B, Q. And solve that to get the total quantity that is the efficient output for this market, right? That is going to be QE is equal to one over B times A minus C. Note, this is the case that this is related to, where we have the constant marginal cost. The total Q, right, is going to be the total supply from both firms, Q1 plus Q2, and that is two-thirds of 1 over B times A minus, times A minus C. Much like the monopolist outcome, which would have Q M less than QE as well, right? We have QE as the efficient output here, and a QC that is 2/3 of that. Now I can't draw a useful set of lines on here that shows me exactly what the individual duopolist profit maximization problem looks like in this space, because that's not clear. But what I do know, and you could solve very quickly, well, hopefully pretty quickly at least, you could solve that for a monopolist, what their marginal revenue would be for this this generic inverse demand curve, and with this marginal cost, what their optimal output would be. And what you would find is that the monopolist outcome is even more restricted in output, and therefore creating even more deadweight loss, right? Because this is the deadweight loss that the duopolists are creating. QM would be 1/2 of 1/B A minus C. Right, so the more market concentration, the finding that we will be able to show, particularly when we get to part 4 of the lecture, where we talk about even more firms, is that the more market concentration there is, the greater the firms are going to restrict output below the efficient outcome and create deadweight loss. And the more firms there are in the oligopoly, right, the more the competition between them is going to increase the total output that they produce. All right, that's all for this part. Next, we'll have asymmetry and show how we solve a case where firms don't have the exact same cost function.